managed to work through all of our colourless cations to find out how to show that each of them is there and which equations that I need to write. Using page 47 of Beginning Chemistry, we've got a really good flowchart that will help us work through this. We know that the next one is going to be zinc, but that's not enough for us to conclusively state that it will be. We need to actually prove it. So we're going to go through those same series of experiments and therefore the equations that go with them. So my first one is to add a little bit of sodium hydroxide, and I get a cloudiness in the test tube. And then I add excess, and it doesn't just dilute the cloudiness. If I give it a wee bit of a shake, all those little flecks are gone, it's redissolved. So that's what I'd expect for aluminium, lead and zinc, so it's not a surprise. So I've added 2 to 3 drops of sodium hydroxide, and I got a white precipitate. Then I had excess NaOH, and it redissolved. The reason I'm leaving space is that we're going to put equations in these. The flowchart that I'm working with then tells me to take a new sample. So I've got that prepared already. And it tells me to add a few drops of potassium iodide. Now, if this is lead, it'll go a brilliant yellow colour. Anything else, no reaction at all. And lo and behold, I'll add a bit more just in case. No, nothing at all. So I'm really lucky. I don't have to write a chemical reaction for this one. I've added Ki, no reaction. My flowchart then tells me to take a new sample. So I'm going to do that again. Don't need space here because there's no chemical reaction here, no equation. And what it's telling me to do is to add a little bit, just a few drops, of ammonia. And sorry, I'm just quickly hunting out my ammonia. And see what happens. I'd expect a cloudiness to occur. And there it is. There's my cloudiness. Now that's not because of the ammonia molecules. That's because of the hydroxide. So 2 to 3 drops of ammonia. We get a white precipitate. Now that's due to, the white precipitate is actually due to the hydroxide ions because ammonia is a base. Then it tells me to add excess of it, or I might want to add concentrated instead. I'm going to go the excess first and see if anything happens. And it is, so that's really good. What will start to happen is, you'll see it started to dilute it out a bit, but there's still bits of solid in there. So when it says excess, it means serious excess. I've got to add even more, because that might just be diluting. And now, there we are. It's now redissolved that precipitate. If I'm unsure, I add a little bit of concentrated ammonia. And sorry, I'll just do that off screen. And sure enough, it redissolved our precipitate. So, excess or concentrated ammonia it redissolved. Now, of the chemicals we work with, only zinc will redissolve with ammonia. Only zinc will redissolve with ammonia. All the others will form a, well, most of the others will form a precipitate with it, but they won't redissolve with it. Okay, so time to do some chemical equations. And by the way, these are all summarised on page 42 if you're forgetting those. The nice thing is there's a bit of a trend coming in here. You'll see with these complex ions down here and here. Zinc's a really good one for getting excellence in because there's more than one opportunity to do a complex ion equation. The first of our equations though for zinc is simply it forming that white precipitate, which is zinc hydroxide. When I added excess, this stuff, the zinc hydroxide, will react with 2 more OHs. You'll notice there's a bit of a trend here. There's always 4 OHs in these complex ions. It redissolved, so it must be a complex ion. ZnOH4, 2 negative. Why is it a negative ion? Because zinc has got a +2, and there's 4 negative 1s. So 2 minus 1 minus 1 minus 1 minus 1 is negative 2. No reaction in the next one, so I don't have to write anything. Now, ammonia is a base. So it's not actually reacting with the ammonia here, it's reacting with the hydroxides in the solution. So this is actually the same equation as this one, which makes this next one a little bit tricky, because you're starting with zinc hydroxide. Then you're adding lots of ammonia, and if you're unsure, it's 4. Okay, there's a couple you'll learn off by heart. But if you're unsure for complexes, it's always 4. Nice little rhyme as well. Unsure, it's 4. What that's going to make is this complex, ZnNH3,4. Now, ammonia is a molecule, no charge. So this thing has got a 2+ charge. Now, here's the thing that most students forget to do, and it costs them excellence. There's 2 hydroxides there, so you need to put the 2 hydroxides as a product as well. Alright, so now we've gone through every single one of the colourless cations and every single one of the coloured ones. There are lots and lots of complex ions that you need to remember. There's 2 in the zinc one, there's 1 in the lead one, there's 1 in the aluminium one, and then there's also the copper one with 2 ammonias, and there is the one for iron 3+ that goes blood red. So that's all of the stuff you need to know for, or remember for, identifying cations. The best thing to do now is to practice doing it with some unknowns in class.